Okay, welcome to Probability and Statistics 300. So this is basically an introduction to the course. We're going to go through the syllabus. We're going to look at My Open Math. We're going to talk about the first challenge. We're going to do a bunch of stuff. So imagine that this takes the place of the first day. That's how I'm imagining it. I'm going to tell you a little bit about myself, how I've arranged the course, what I expect from different parts of it. So I think you'll find it very useful. There's also things that are in this first day welcome speech that are nowhere else. So be sure that you take the time to go through it. Imagine this is the first day of class, but you haven't had to take the bus to school or drive to school or wander around looking for a parking spot somewhere and then finding the classroom and all that good stuff. So you're already there, you're already set, life's good. So first off, I've taught at CSUS, I've taught at UC Davis, and there are many things. There are many reasons that I prefer teaching at American River College, and since I was a student at all three as well, there's many things that I enjoyed about being a student at American River College over the other two as well. Some great things at CSUS and UCD, but we have a lot to offer as well. One of those is class size. We have small classes, which means that getting in touch with me is part of how I conceive of teaching. So I encourage you to do that. Getting to know your other classmates. Someone has already posted on the forums that she's hoping to start a study group. These are all great ideas, and a small class size really makes that work. Access, just the fact that we're in the community, it's fairly hard to get down to UCD. It took me 3 buses to get down there when I was a student. Your library card will still get you on the bus, so wear your mask and get out there. The Learning Resource Center is where we have all of our tutoring. That's all online, and that is very valuable. Successful people get help. That's kind of how it works. So make sure that you see that as a way to succeed. You see that in positive terms instead of in negative terms. So a little bit about me. I started at American River College. I started when we had different numberings for courses, and the campus was much smaller. We only had about 10,000 students in those days. We're up into the 30s now. So a different school, a very small, kind of very friendly school. And then I got my bachelor's from CSU Sacramento and my master's from UC Davis. My area is combinatorics. Combinatorics, if you search for it on like Wikipedia or something, is about counting, and that's certainly a good way to look at it. But this picture that you can see is actually of an early supercomputer. So the blue kind of haze inside of it, behind that glass, is wire. So this supercomputer does not have a clock. There is no system clock in this thing. And the way that it can get away with that, in other words, the way that pieces of data don't run into each other and questions get answered before they're even asked somewhere else by the computer, is that every pair of components in this computer is connected by exactly the same length of wire. Now, not having a clock in a supercomputer is a really good idea. You're basically saying that it's calculating as fast as it physically can. It's not artificially being slowed down by a clock. So it's a good idea, but it's not the best idea. There are other ways of designing computers. There are other ways of designing bus routes and airline networks and the ways that packages flow through freight services that are much more efficient. The Berlin airlift is an example of that. When push comes to shove, we can usually make things a lot more efficient than they are now. Now, efficiency is a word that sounds somewhat abstract, but I think of it as being able to do more with less. And we need to be able to do more with less. So thinking mathematically, thinking about how networks work is kind of my area of mathematics. In terms of being a faculty member, I've been on the faculty senate through some kind of strange times. I've served on evaluation committees for my colleagues. I was on the equity committee from the very start. I've served on a lot of hiring committees. We've got some good people, younger faculty members coming up. And something I'm particularly proud of is my work with open source. I have actually coded homework, which means that I write the code that creates the question. So the algorithms that actually make the questions that you see when you log into My Open Math. So that's fairly far outside of my training as a mathematician, but I've really enjoyed that, and it's really allowed me to conceive of teaching online as a very collegial activity with other math professors from around the country, and opening the door to providing high-quality math instruction for free, not just here in the United States, but everywhere in the world. So I'm really pleased with that. The text was written by Kate Kozik. She is a community college professor in Flagstaff, Arizona, and has created an excellent text. I created the workbook and many of the videos, well, all the videos that accompany the workbook. There's texts out there I've written, algebra texts, and all sorts of good stuff. So right now I'd like to introduce our first challenge. So I'm going to point that out. The challenge is due at the end of the week, and that is, so I'm going to pull up where that is so we can see that. Okay, so here's our workbook. You've got either the printed version already or emailed me for the PDF if it hasn't come yet. And if we scroll to the table of contents, you can see that there are several projects, and the first one is this welcome project that occurs on page 141. And so let's pull that up. So here's project 1 from page 141 in our workbook. Notice that there are some warm-up questions. So there is a video for this already posted in MyOpenMath. So if you log into MyOpenMath, the first thing that you'll see is, let's go to the student side, is the attendance homework forum and the project 1 video. You can click on that and that'll step you through that first project. So there it is. And I've got it muted so you can't hear it. Let's back out of that and notice that there is then a extra credit project that's due on Friday to get you started. So that's our first challenge. Let's go back and just look at it for a little bit. So the first 2 questions basically are about how English works with mathematics and how often in English we don't use it correctly, but we expect people to understand what we mean even so. And the next 2 questions are basically asking us to start to think mathematically. And in an algebra context, which is pretty much all we're going to use in statistics, a lot of arithmetic, is the idea of undoing, of working backwards, of knowing where we stopped, trying to figure out how we got there. So that video will step you through these, and then of course the project will ask you some questions. This first one is entirely extra credit. So every Tuesday this semester we've got a chapter exam, a midterm, a pre-final, a final, or our climate change video later in the semester. But for the first week of the semester, I've done things a little bit different. So instead of having an exam this week, we're going to have our first documentary, which is NOVA Prediction by the Numbers. So let's talk about that. This is an excellent introduction to a statistics course. It gives you a sense of what statistics does, its history, its power, how it's being used today. It is a great way to start the semester. If you've already seen it, you know that it's very good. It'd be excellent if you could watch this with members of your family, people you live with, just to give them a sense too of what you're trying to accomplish this semester. So that's one difference. Instead of an exam, we're going to have an exam covering a documentary this first week. The other difference is that instead of it being due on Tuesday, it's going to be due on Friday. So the same time as that challenge. So let's take a look at this. I'm going to pull up the syllabus. So here's the syllabus. I'm going to scroll down to the bottom of that first page, and I'm going to click on the hyperlink to NOVA Prediction by the Numbers. So this takes you to American River College's library. So it's loading, I'm hoping. There it is. So here's Prediction by the Numbers. If I want to see it, I can click on Films on Demand. It'll ask me to log in, so I'll do that. And in a little bit, we should see it popping up. So it's an hour long, 53 minutes. It has a lot of people in it who you may already know. And if not, then this is a great introduction to statistics. It's only an hour long, and it takes the place of our first chapter exam. So we're not going to have that until next Tuesday. Not the first week of the semester, but the first chapter exam is the second week of the semester. Our big exam is covering prediction by the numbers. So I really recommend that you watch it 3 or 4 times. Take notes. There will be an exam on it. So let's take a look at how that will go. So if we go into My Open Math, we can see that this semester, let's go to the student side, good. And we've got that documentary NOVA prediction by the numbers. So this first link is simply another way to get into it. So you can use the syllabus or you can use that link from inside of My Open Math. Now, watch it once just to get a sense of what it's trying to accomplish, just to see the topics that it's covering. Watch it again and take really detailed notes. So at that point, be pausing it and making sure that you've captured what you need to from it. Then there's a sample exam. Notice that that is due on Friday, but it is entirely optional. It's a sample of what the exam will look like in terms of the number of questions. So you'll have about 10 minutes and 5 questions. It'll be free response, and you can do that anytime. Every student will see the same 5 problems, and then of course those few problems won't be part of the collection of problems that the exam itself is taken from. But let's look at that sample. So here are some sample questions. So notice that it says that it's an important exam. It has a due date and a time limit. So with your notes sitting right next to you, you can get started. So here's a question. It says after the ox weighing context was over. So that's a nice little bit of context to remind you from where it was in the documentary. And then you'll click and enter text. So here's the 5 questions that I chose to put on the sample, just to give you a sense of what that exam will be like. Okay, let me remind you where that is in My Open Math. So when you're in My Open Math, you'll see the Project 1 video, the Project 1, and then the link to the documentary at the library, so that streams, then the sample exam, and then the exam itself. So instead of being due on Tuesday, this is due on Friday, just like the project. So as a summary of what is due just the first week, we've got the welcome video. You're watching that now. There's another welcome video that discusses the projects. There's the homework forum. It would be great if you could get into the welcome forum and introduce yourself. There's also the first project, and that has a video, and then there's the project itself. There's the documentary, a sample exam, just to check out your notes to make sure they're good enough and that you can answer those questions from your notes in the time limit. And then, of course, the exam covering our first documentary as well. And if you're new to My Open Math, if you haven't used a calculator in a while, or if you want to see the power of entering stuff, remember there's that Getting Started file as well. And that will close on Tuesday. Now let's take a look at the syllabus and My Open Math. So I'm going to first give you a quick overview of my goal for the course, and then we'll look in more detail in the syllabus and My Open Math. So there are no makeup exams. You need to attend. And attendance is still the correct word even for an asynchronous online course, and we will be talking about that. That requires you to do what would have been considered homework in another course, basically ensuring that it's working for you, that you're in the right place and you're doing the right things. So I've broken this text into this course into several pieces. First off is the text and the My Open Math homework. The idea there is that it is abundantly clear. That is entirely about skills. So skills, just how to do things, using your calculator, not a lot of critical thinking going on there. Instead of a reading, this semester I have a documentary. That's NOVA's prediction, and I think you'll enjoy it. I really do believe that. I enjoy it when I watch it, and I've certainly watched it many times. The idea there is to teach you the breadth of what statistics is able to accomplish and what its values are, what its philosophy is. There are challenges. They are meant to be engaging. That means that you have to think about them. They're not something that will be obvious. They're not the first response that you'd have to something. And that's basically to illustrate that statistics helps us to reason. It helps us to get past our initial response to things, which is very often a socially trained response. That also is to show you how statistics actually works, how we apply it. And those of you in the companion course, we've got a pre-algebra section that'll just teach you, I use the word teach, but remind you of the math, and then some challenges that highlight the rigor and really the fact that math does a lot of things that statistics could never do. So let's take a look at the syllabus. Okay, so here is our syllabus, and as it says, Introduction to Probability and Statistics, that is Stat 300, and this is an asynchronous class, which is huge. Many times over the course of the summer, as I've been planning this class for you, it's become abundantly, painfully clear to me that to teach well, for you to have the tools that you need to learn well, but also honor what it means to teach an asynchronous class, there's a lot of compromises. There's a lot of things that are not like a in-class online course where everyone logs in at the same time and asks questions at the same time and hears other people's questions and everything that kind of emulates a class. So be very sure, be very clear that you are in an asynchronous class. This class is not delivered so that you have to take it at a particular time. You can be working on this class, and the way I've designed it is that everything gives you 2 weeks from start to finish before the deadline. So you've got to balance that time yourself when you're going to be watching the videos, taking the initial quizzes, doing the attendance, taking the place of homework, when you're going to be taking those chapter exams. So a lot will fall on you, and certainly a lot more fell on me, just in terms of getting resources that could be used in the morning, in the noon, in the night, on the weekends, on Tuesday afternoons, whenever it is that you have that time. So that is a key component of this course. That is, in one sense, the single most important direction that this course had to take. If that does not work for you, then get in touch with me or the dean pretty darn fast and get yourself into a class that meets at particular times, just remotely. In fact, those classes could be considered remote. This one is not only being delivered online, it's also being delivered at who knows what a time. So I've got to get a lot of resources out there for you to make this work. So that said, welcome. So we're going to be using algebra, a lot of arithmetic, to discover something of the nature of probability and statistics. The idea here is to learn enough probability and enough statistics to actually be surprised by it, to actually have it tell you that it has value, that there are times when you need statistics to avoid bias, to avoid simply falling in the trap that everything looks the same. So welcome. This is Introduction to Probability and Statistics. My office hours are 8 to 8:50, Monday through Friday. That could easily change. I definitely get in touch with you. This doesn't mean that I will only be able to contact you or you'll be able to contact me at those times, but it means that I will be almost certainly answering forum posts and emails at that time. So that is something that I would much rather have simply been, whenever we need to get in touch. Whenever you send an email, I'll try to get back to it as soon as possible, but that's required that we have office hours. This is a 4-unit course. There's 2 sections that I have this semester, one with a companion and one without a companion, and of course by email. You're getting a ton of email from me, and that's the address that it's coming from. So ethical conduct is about cheating. Now, I've designed this course so that I don't see the need for cheating in the classical sense. For example, I let my lecture student have a note card, assuming they've earned at least 90% on their homework. So for a very long time, I have loosened the restrictions on what it is to have resources with you. So I am perfectly clear with the fact in my own head, and hopefully in yours too, that you're going to have the book, you're going to have the workbook next to you, you're going to have your calculator, you're going to have your notes, all good stuff open and ready as you're taking these exams. So what is cheating? Cheating is when you present someone else's work as your own, or when you let someone else present your work as their own. Now, there's all sorts of ways you can cheat. There's ways you can get caught. I don't need to go into that. And the responses to that, of course, would be being dropped from the class, receiving an F, or even being dismissed from school. I serve on the committee that deals with those sort of things. So let's look at this from a positive point of view. What is an education? It's not just to get a piece of paper. So what does it mean? As a student, your goal is conceptual understanding that allows you to solve problems in other settings. So if I ask you a question, understanding is demonstrated by being able to solve a similar question. When asked, you will be able to explain your reasoning in your own words and solve similar problems. So that proves that you know something, and I think that's very satisfying as a student to have that degree of understanding available to you. You're going to be working at home. What do you need? So home learning materials, and as I said, have them handy, take advantage of them. There's no need to imagine that you can't be looking at your book or your workbook during an exam or as you're working through your attendance. Just be okay with that. It's sitting there, it's ready for you. So you should have the text, Statistics Using Technology. That's the second edition. We'll talk about that a little bit more in a sec. I'm pointing out that that is the second edition. The third edition of Kate's book only has R code. It no longer has anything for calculators. So you really do need the second edition. She teaches at a school in which everyone has computers, and that's beautiful in that situation, but AR chose not to go there. We've spent our money other ways. The Probability and Statistics Workbook, that is essentially the thing that I created when I was imagining teaching this class in a hybrid setting, some in class and most online. But the workbook is basically your notes. The workbook allows you to have a really good sense of what it is that I'm looking for handy all the time. You also need a computer for this class, and that's primarily for R, but basically because virtually everything is going to be delivered via a computer. I use a Linux. I use Ubuntu Linux. I have used it for 7 years now and would never go back to the Macs and PCs that I used before it. You can get a computer for $120, a Raspberry Pi desktop kit with postage is less than $140. You plug it in with an HDMI cable to a television. So there's computers out there that are less than textbooks. A Mac is fine, a PC is fine. Notice a Chromebook isn't really a computer in that sense. You can emulate it in certain ways, but you have to be pretty tech savvy to do that. You're certainly free to do that, but I haven't listed Chromebooks for that reason. I have no interest in dealing with things that require emulators to run on them. That penguin is called Tux. Tux is the mascot for Linux. You'll certainly need notepaper and a pencil to work through the workbook. You'll be watching videos, me going through the workbook with you, and as we do, we'll answer questions, we'll work through harder problems step by step. That is the closest thing to emulating a classroom environment, is that development of an idea together. So pencil and paper for that. The paper more for when you're working through your homework so that you've got notes for the midterms, for the chapter exams, and then of course for the final as well. A TI-84, you need to have the course applications installed, that is Bell and FitTest. Bell and FitTest are both inside of My Open Math. They're inside of that course information tab. And you download them to your computer and then use the cable that came with your calculator and the TI Connect software to load it from your computer to the calculator. There are so many advantages to using these two applications. FitTest makes the end of the semester such a pleasure in comparison to what it would be without that. And the entire middle of the semester will be using Bell. These are two applications that were written by a colleague at Fort Steilacoom Community College in Washington State, and they are great. So I have his permission to use those and distribute them. They are really helpful. Let's look at one of our first quotes from Albert Einstein. How is it possible that mathematics, a product of human thought that is independent of experience, fits so excellently the objects of reality? We don't perform experiments. Modern statistics, Bayesian statistics, accepts the idea of simulations, of stochastic methods. But in general, math is done in the brain or in a computer's brain. It's not done with the cool toys that scientists have. If you come into a math classroom, there's a whiteboard in the front, there's desks, and that's it. That's where math happens. We don't need stuff. We don't perform experiments. Math is deductive. We take relatively straightforward truths and we see what the consequences of those are going to be. This is a very philosophical question. So when you're thinking about this, if this captures you, you're definitely headed into mathematics or philosophy. It is an interesting question because math, of course, precedes science. There has to be developments in math before there can be any development in science. And, of course, none of that is done with experiment. It's done independent of experience. It's done entirely in the human head, a product of human thought that is independent of experiment. And I have a lot of theories about this. As a mathematician, I find this a fascinating question, and I hope you have some time to think about it as well. Okay, now we're looking at the required text, Statistics Using Technology. That's the second edition by Kate Kozik. There's the ISBN, so you can get it all sorts of different places. And then a hot link into Lulu. So let's take a look at that. So I'm clicking on that link and it's taking me to Lulu. So I see that there is a sale that ends relatively soon. I see that it is $8.48 and I can add it to the cart. 458 pages, and the author I attributed to Kate Kozik. The next is the required workbook. That's what you'll be using basically in place of class time. So you'll be watching the workbook videos and following along. Again, following that hot link, you can see it's $10.46. It costs a little bit more because it's spiral bound, and that allows it to sit flat on your desk as you turn the page, which makes it a lot easier. It's not trying to close itself like a perfect bound text would. The homework and videos are all inside of MyOpenMath, as is the forums for asking questions and a bunch of other things. When we go into MyOpenMath, you'll see that. There's the second place that the course ID and enrollment key are. You've also got my email showing you the instructions to log into MyOpenMath and do that. Another hot link, this takes you to MyOpenMath itself. The next link is to the statistical application RStudio. It also requires R. I've sent out all those links as well. The next is our calculator. Our documentary is Prediction by the Numbers. There's its ISBN, and then a hot link to the library's permanent link to that material. And then our second quote is from Galileo Galilei. The book of nature is written in the language of mathematics. I think it's a profound thought to think that behind all of nature, beyond all of science, is mathematics. And I think that that's exactly what Galileo was saying with this. To understand nature, human nature, our societies, our economies, our pandemics, our ways of producing things, all sorts of stuff, we really do need to understand mathematics. I allow my students to use calculators on exams, the midterms, the finals in a lecture class, and you'll be in the same situation. Having Bell is such a beautiful thing to have beginning in Chapter 6. It's so important to spend the time to plug that USB cable in, to install the TI Connect software on your computer. If you didn't get a calculator that came with the software, download TI Connect for your machine. There's Linux versions, there's Mac versions, and there's IBM clone versions. It's so useful to have that. At some point, we might move to what Flagstaff has moved to and use R for everything, but we're not there yet. The next topic, of course, studying and attendance, which is you can think of as homework. There is no homework per se anymore because the entire class is at home. Studying is the single most important task to pass this class. Not doing homework, but studying, thinking about it. There's a difference between doing and thinking. Thinking is a different kind of doing. It's when you're abstracting and generalizing concepts. Those are the two hallmarks of mathematics. If you can generalize, if you can abstract, you can lose the specifics of a problem and see the big picture. You can understand everything at a glance. Studying, and I'm reading this again, is the single most important task to pass this class. Give yourself time to study regularly. So study the section, read it, but you'll hear the same words in the online lessons that I give you. You'll see the same words and the same concepts in the videos. So when you're doing this, think critically about it. This is the one setting that you are completely in control as you read. So read, look back at a section, look at an example, really be critical. So read that section of the text, note any new ideas in the section, make sure that you can explain any new ideas in your own words. Now that's a hard thing to do, but it is terribly important to be able to put ideas into your own words. If you've got questions, write them down or go straight into MyOpenMath and post something to the forum. Make clarifying notes as you work through the homework. Complete the attendance assignments. So that proves that you're here, that proves that you're making progress, that you're ready for those chapter exams, the midterms and the final. That will feel like homework in the sense that it's fairly forgiving. You've got more chances, 3 tries for each of those. If you have a question, refer to your notes and then the text. If the text can't answer your question, post it to the forum. And then read the next section of the book. Reading is important, and reading puts you in the mindset of doing mathematics. Mathematics is deductive. We're not experimental. We start from a big idea, and the text will lay that out for you. Reserve at least 1 hour for studying each day. At least 1 hour for studying each day. If this class is here and there, and you try to log in and get stuff done 1 day a week, it will be tremendously difficult. And that I wouldn't wish that on anyone. So break it up into little pieces. Work a little bit each day and 9 hours each week. 9 hours each week is the average. There are chapters in this book that accomplish a lot. We have 1 chapter on binomial distributions. We have 1 chapter on probability. So make sure that you've got more in reserve than 9 hours. Make sure that your friends and your family and the people you work with know what it is you're trying to accomplish this semester. And know that there'll be times when you'll be working 15 hours in a week. There's nothing wrong with that. If I was taking this course, when I took statistics, I worked very hard at it. And that is another hallmark of mathematics. There's chapter exams and there are midterm exams. So basically the distinction between those two is the amount of content that they cover and the detail in which they ask their questions. Chapter exams very detailed about an entire chapter. Midterms about half of the text. Any other class, this would be a 2-semester class, but statistics has been for a long time for a few people going into medicine and other disciplines. We'll talk about other ways of satisfying this requirement. Most majors in the CSU system do not require statistics. And I guess I should point out, because this is in our very formal way of saying things, just going back to the previous section, completing each attendance assignment on time is a course requirement. So course requirements are basically things that you have to do in order to remain in the course. I'm going to point out the obvious. Exams which are missed earn no points. So that doesn't mean they go away. That means that they are basically increasing the denominator and not the numerator and making it hard to pass. Attendance. Be an active learner. Critically examine what you learn in the online sections. Now, it's easy for me to say that because I know a little bit about different kinds of statistics. I know a lot about Bayesian statistics. I know a lot about modeling, which are different from classical statistics. And you'll hear me say that over the course of the semester. And I'm not doing that in any way to belittle the role of classical statistics. I'm simply doing that to encourage you to bring your own critical thinking to this. You can be critical too. And I hope that throughout the semester, when you hear me say, and this is how I'm supposed to teach a classical statistics class, you are thinking to yourself, well, I've got some experiences of my own. And in classical statistics, I'm going to give you one quick example. If you flip a coin 100 times and each and every time it's a head, and I ask you, what's the probability that the next toss will be a head? You are supposed to say 1/2. A fair coin, each head or tail has a probability of 1/2. But I think enough of us have been out in the world to know that that coin probably has 2 heads on it. There are such things. In other words, we're probably being lied to. And some other way of thinking that says that we're supposed to get a head or a tail equally likely probably isn't working. Be critical of this. Now, that doesn't mean that there are times that you and I have to accept classical arguments. What it means is that I don't want you to blindly accept them. I want you to be really critical of this. Don't assume that because something is in an introductory statistics class, it is the only way of thinking. In many ways, the things that we present in this class have been discredited for decades. But regardless, if you take away from this course the idea that you can think critically about things, if somebody tells you that something is good and something else is bad, that's another context that I would encourage you to be critical about. Take excellent notes as you work through your assignments. Explain everything as you would to yourself 4 months from now when you're taking the final. Do everything you can to make your life easier the day that final comes. Of course, those midterms as well. Online assignments serve as attendance and is a course requirement. Students who miss 2 chapter attendance assignments will be dropped from the course. So miss means that you didn't make it up to that minimum 80%, and so you will be dropped. Of course, get in touch with me if something else comes along, and we can certainly work through that if I know what's going on. So our next quote comes from Lynn Steen. Despite an objectivity that has no parallel in the world of art, the motivation and standards of creative mathematics are more like those of art than of science. Math and science are essentially the same thing, different manifestations of the human ability to look inward and to find things that haven't yet been manifest in the world. Mathematicians do that to lay the foundation for science. You can make the argument that artists do that to lay the foundations for our society, to see ourselves, to critically ask, is this the world we want to live in? Lynn Steen was president of the American Mathematical Association. Assigning grades, this is completely typical. There's nothing in that grading scale unusual. Anything in the 90s is an A, the B is an 80s, C in the 70s, you get the idea. There's lots of ways to determine that, demonstrate that you know what you're doing. The attendance assignments, the place, kind of taking the place of homework, 10% of your score. A lot more work than that, but 10% seems fair as you go through that. We're going to have an exam on the documentary Prediction by the Numbers, and then near the end of the semester, another exam covering climate by the numbers. So 5% for that. Our projects are 15%. A lot of critical thinking there. A lot of things that may initially seem counterintuitive to you. Chapter exams, the largest source of points in the entire semester, 30%, about 1 point in 3. The midterms, 20%. There's 2 of those, dividing the semester into 2 pieces. and of course the final 1 point in 5, 20%. We'll return to talk about these some more. For now, basically notice this. It's easy to say, oh my goodness, there's all this stuff. The better way to look at that is to think of the law of large numbers. The more assessments there are, the better that average is. If I give you one exam and you're just feeling great and life is good and you've had time and you got sleep and you've eaten well and everything's fallen into place beautifully, you'll do well on it. And if you haven't, you'll do poorly on it. And that certainly tells you how you're doing that particular day. But the more kinds of assessment there are, and you can see I have lots of different kinds of assessment here: chapter exams, midterm exams, final exams, projects that are very thoughtful, a documentary that you can watch with your kids or your parents or your significant other, attendance, just the idea of plugging away the work of being a math and statistics student. I'm really trying to get lots of data points, and as a statistician, I really want lots of data points to be confident about the grade that you earn at the end of the semester. I sent out an email about configuring your email, so if you haven't yet, go into your email and configure that. Online etiquette. It is so easy when you're not sitting in the same room with someone, when you haven't kind of seen their humanity face to face, to be a little bit less respectful. So I try to be even more respectful as a kind of consequence. I try to assume that I'm talking to someone just like myself who wants to be treated with respect. So I really encourage you to do that. Demonstrating respect at all times is a course requirement. Now, I'm not just talking about myself, but any interactions you have with other students. To me, that is far more important that those are respectful. They can certainly be casual. We are all Californians. You've seen my email. I sign them Ben. My name is Benjamin. You do not have to call me Professor Etgen. You certainly can call me Professor Etgen. Avoid any disparaging terms. There is no list of disparaging terms. Just be thoughtful about that. Be thoughtful about anything that puts up an us versus them dichotomy. Anything that is, they are different from me, that almost certainly, when there's a power dynamic thrown onto that, becomes disparaging. So just think of us all in the same pot, trying to accomplish the same goals of learning statistics and making the best of this situation. Be respectful and think, students. The majority of the answers, the vast majority, are going to come from your colleagues, from other students. I'll be in the forums. I'll be monitoring them in case there's anything terribly strange. I'll certainly provide feedback behind the scenes directly to any students who answer questions. But be thankful for that. It's nice that we live in a society where we have enough technology that we really can share in a convenient way what we're good at. Dates to remember. There are some holidays, amazingly. If you end up working on them, you can say that they're investments in your future, in your children's future. You know, if you take care of your parents, you can see it as an investment in taking care of them. And then our last quote, maybe most important in some sense, from the Reverend Martin Luther King Jr. The function of education is to teach one to think intensively and to think critically. Intelligence plus character. That is the goal of true education. I would rather teach at a community college than an Ivy League school, and that's because I have taught at American River College full-time for 18 years, and I can tell you that, just like I was when I was a student at AR, we are thoughtful people trying to make the world a better place, and there is nothing better than that goal. So intelligence plus character, that is the goal of true education. So as this semester progresses, there may be days that you think to yourself, I can't get this idea. Well, remember what the Reverend Martin Luther King said. Character also counts. Sticking with it also counts. Asking questions, that counts. Being thankful when someone helps you out. I'm certainly thankful when people help me out. There's going to be a lot of things this semester that will try that. That'll try our patience. That'll try just the amount of work that we have to do. And at some point, you'll have to, I hope, remember this and think kindly on yourself and everyone else around us, trying to do the best we can. The next page is a list of everything that you are supposed to learn this semester. So let me say that if you're starting a college level stats class and it's entirely online and it's asynchronous and you're looking at a syllabus, it's already got a ton of stuff in it, you turn the page and you see this, let me say that I am told that I have to put this in the syllabus, so in no way do I feel that you have to look at this. This is a legal document, and so when you're looking at it, this is basically saying what you're going to be tested on. But if this was me as a student, I would ignore it. I don't think there's anything to be gained from looking at a humongously long list of things that I will be learning. So there it is. Has to be there. It's there. If you want to read through it, I mean, it's kind of funny. You can start grabbing some funny phrases and start using them in your life. I mean, have you done any least square regression today? I think you probably should. It's pretty darn easy to make some jokes about doing modeling. So my only point in this is don't let this throw you. Anytime you look at a new index for a text or a new semester, there's going to be a lot of things there. Remember, I have to put that there. I do not expect you to read that. There's a ton of stuff there, and we've got a long semester, and I've been through this class many times. We can pace ourselves and we'll be able to get through. The pursuit of excellence in the face of adversity is invariably matched by the glory of the result. Now, let's be very clear on what that means. That means if you're the first person in your family to go to college, the glory of that result is greater than someone who had an easier time. The amount of work that you put into this makes that result that much more glorious. And that's a photograph I took on Twin Peaks in San Francisco, just a beautiful plant growing in something that looks completely and utterly inhospitable. My office is right here in the corner of Howard Hall. The bus stops are where they've always been. There's the number 1 stop right out in front of my office. Here's the number 82 stop that I use to get home. We do have a final exam coming up. It's hard in our society to sustain an interest in hard things. It's easy to sustain an interest in stuff that's advertised on television, stuff that is easy to consume. It's hard to dedicate yourself to math, science, engineering, technology, or medicine. And so seek out people who are going through that same process and make friends with them. And when you have left this class and you want to keep in touch with a mathematician, you're certainly free to keep in touch with me as well. Okay, last but not least, any changes that are required to be made, I will certainly tell you about that via email. I've been teaching for 18 years. I certainly don't expect that to be an issue, but I'm always open to making things better. Notice that everything happens on Tuesday for the main course and for the projects on Friday. So I've broken those up. So first off, welcome. So there are some welcome assignments that are due. When we talk about My Open Math, you'll see that. There's also a welcome project. I've shown you that already. That's extra credit. That is the only one that's extra credit, just designed to get you into the routine, to have your attendance, chapter exams done on Tuesdays, and to have your projects done on Fridays. What this means, if you're wondering what a calendar means in an asynchronous course, it means this. It means that these are when the deadlines are. I'm going to allow you to get into not only that week's assignments, but always the next week's assignments too. So you've got 2 weeks to get things done. So whatever that means for you, whenever you've got that time, these are the deadlines. So make sure that you see that things have to be done by this time. And when we get into My Open Math, you'll see that when it says Chapter 1, for example, on September 1st, there's a lot of things that go into completing Chapter 1. So a lot needs to be done by Tuesdays, and then a lot of thinking needs to happen by Fridays. We have 2 midterms as well, so let me scroll so that we can see both of those. Now, at this point, you might be thinking, my goodness gracious, so many exams, so many different kind of exams. The questions for the midterms are taken from the chapter exams. The questions for the final are taken from the midterm. So it's like a triangle. Lots and lots of questions on those chapter exams, but gradually the more important ones show up on the midterm and then again on the final. The idea here is that it's easy to learn something. It's also very easy to forget it. It's harder to retain it. So the midterms really encouraging us to keep on top of things. The final itself is somewhat unusual. I'm sure you can tell from this that I have both a pre-final and a final itself. And there's a lot of reasons for that. One is that a final is a huge amount of the course in terms of the credit needed to pass. And that's stressful. I know it's stressful for me to think about taking finals. The pre-final is, in many senses, a final. And if you like your score on the pre-final, you do not need to take the final. In other words, this provides a kind of built-in safety net for that last and most important exam for this semester. Okay, notice that there's 11 chapter exams. Okay. Now let's go back to that first page. Okay, so here we are back at the page that started this all. I'm now going to go into My Open Math. Before I do, let me explain the presence of Frances on this slide. You're almost certainly going to hear her over the course of the semester when the letter carrier comes, or if she hears something, you might hear her start barking. So she's the accompaniment for this semester, at least at my end. And also kind of the reason that I force myself through to pay for her vet bills and her dog treats. So let's take a look at My Open Math. Okay, so here we are inside of My Open Math. This is the student view. First thing I want to point out is the Course Resource tab at the very top. When you click on it, a bunch of stuff loads. There's the syllabus if you want it again. The course information, Kathy Kozak's book can be read online. You can download a PDF of it or another link to the printed copies. The workbook was created by me. The homework and workbooks were developed by, or just the homework was developed by a professor at Fort Steilacoom and myself, and I made all the videos. The course itself, like the workbook and the text, is a Creative Commons share and share alike license. Go into the welcome forum and introduce yourself. There's 10 points up for grabs for doing that. And basically, it makes me feel good that I know that students are in and ready to get stuff going. So getting started is our first assignment. So let me click on that and show you what's going on there. So it says that 90 points are possible. It says that it's due on Tuesday by 11:55 p.m. It looks like I already started it, so let me do this again. So it's basically an assignment that ensures that you know how to enter things calculator style. So My Open Math has the ability to use parentheses, just like your calculator does, and you'll need to do that as grouping symbols. So it says we're supposed to enter this number 7.1234 and submit that, and it says, yep, I happily did that. This is by far the easiest assessment of the entire semester. It's basically getting you started using algorithmically generated homework. So I'm going to submit that. Oh, not changed since your last submission. Okay, then I'm going to go to the next question. And it says, my golly gosh, how do you enter things? So I enter a square root with SQRT. I enter grouping symbols with parentheses. I enter exponents with the caret symbol. So this, it wants me to enter the square root of 5 over 2. Notice that the moment I click on it, it shows me the, that's called Math Quill. That allows you to enter things symbolically as you see it. I'm going to enter it calculator style first, so the square root of 5, and then I'm going to arrow to the right to get out of the radical. So I use the arrow key on my keyboard, and then over, that gives me a denominator. Notice that syntax incomplete has appeared because if you're going to divide, you've got to divide by something, and I'm supposed to divide by 2. So that looks really good to me. 7/3, I'm going to enter that as 7, and then I'll use the slash on the keyboard, thirds. And now we are supposed to be doing some, it looks like, exponentiation. So let's do that. So 6, and then I'm going to use the caret key on the keyboard. That's Shift 6 to get the exponent. You could just as easily click on the exponent key. I'm then going to arrow to the right to put in a denominator, a slash, that sideways slash, and then 3 to the second power. Now, when I've got a denominator, this 1 over, notice that MathQuill now allows me to load this as I see it. So 2 to the third, I arrow to the right to get out of the exponent, minus 3, and I don't have to worry about putting in those parentheses. I'm going to submit this, and it says happy days. And now let's go on to the next question. That was question 2, arrow to question 3. And it says we're supposed to enter as a mixed numeral or in lowest terms. So 7/3 is an improper or vulgar fraction. It looks like 3 goes into 7 twice. So 2 space 1 over 3. Not a valid fraction. Mixed numbers are not allowed. Oh, okay. So what? It didn't want a mixed number. That's fine. What does it want? Must be in lowest terms. Well, 7/3 is in lowest terms. Okay, so 7/3 does not have to be in lowest terms. Does have to be in lowest. Well, 1/3 is already in lowest terms. And this one is in lowest terms. What do they want us to do this? Is this 5 halves that they want? Let's find out. So submit, it said no, it wanted 2 1/2. Oh, we're just entering these. Okay, 2 space 1/2. So that space makes it 2 1/2, just like putting in a plus sign. So let's see if it's happy now. Okay, it's happy now. Good. So submit that. We've already submitted. That's right. Scroll up and go to the next question. You can see that these are basically just asking us to learn how to use MyOpenMath. So this next question says enter this thing. Okay, well, I'll press an X from my keyboard. Shift 6 to get the caret. A 2 for an exponent. I'm going to arrow to the right to get out of the exponent, plus sign. A 4. I'm going to click on the square root symbol, x plus 1. Now, when I arrow to the right, I get out of the radical, but if I click divide, I've got an issue, because in what I'm supposed to be entering, the x squared is inside of the numerator. So I'm going to delete to get rid of that fraction, because it was in the wrong place. And I'm going to put in parentheses. So I actually just used the parenthesis key on the calculator, and it put everything in parentheses. I'm going to then press the slash to get the denominator. And now I've got everything in the numerator exactly like I should, but it's warning me that I can't have a numerator without a denominator. So 5 minus x to the third power. And I click away from that and click submit. See if it's happy. And it is happy. Let's go to the next question. So it's asking me to enter a sine and a logarithm and a pi and an x and all sorts of good stuff. So sin is the sine function. Pi is on my keyboard. So I just clicked it there. Over, so I'm going to click the slash 6. I'm going to arrow to the right to get out of the denominator x. I'm going to arrow to the right to get out of the parentheses plus. The natural log is a function from intermediate algebra. That's an x over 2. And then all of this is over 3. So syntax error just because it hadn't seen the 3 yet. Let's submit that and see what it says. Okay, so it's happy. This is our first assignment. Try selecting right below. Well, let's see, there's a lot of wrongs. I think I will select right there. So there's a radio question, lots of radio questions this semester. We're matching the sound with the correct animal. So a cat, we say a cat meows. So cat is C. You're already bored with this. Dog goes arf, I guess. Certainly not ba. I would think that was a sheep. Moo, I would think of as a cow. So arf, okay, that's fine. Maybe not bow wow or something. And a cow goes moo. And so there's a matching question. Good, happy there. Some more entering questions. So let's see, the square root of 5, and then I arrow to the right, over, I can use this fraction key. 2. Well, I think we did this one already. 7/3. Yeah, we did. 1 over, and then the denominator 2 to the 3rd power, so that exponent key. Then I need to arrow to the right to get out of the exponent, -5. But I didn't arrow to the right twice. If I used the right arrow key twice, I'd get out of the exponent and the denominator. And then log is a function, those parentheses, I'll click on that, of 4. Let's submit this and see if it's happy. It looks like it's happy. Let's go on to the next question. We're almost done. It's asking us to input a bunch of stuff. You get the idea. Okay, that's our first assignment, basically making sure that you're in and you're doing stuff and that your keyboard works and all that good stuff. We've got Math Quill now, which is pretty powerful as we enter these things. So there is our first assignment. Let's go back to perhaps something a little bit more interesting. Let's see more of what's going on in MyOpenMath. So I'm going to click on the course up here. There's the syllabus, the course information, the welcome form, the getting started assignment. Below that is the first of our calculator applications. Here's Bell. So you click on that, it'll download. It's a file. It's in fact a 8xp file, which remarkably is the format for TI calculators. There's a forum where you can ask and answer questions. You can also ask or answer or ask a question from within the question itself. So when we look at the Chapter 1 homework or the Chapter 1 videos, the first thing you'll see is the online lesson for the workbook. So the idea here is that you click on this and you can maximize it to fill the screen. Welcome to Chapter 1, our first look at the vocabulary of statistics.
And as I'm talking away, whatever time of day, whatever day in the week, maybe even as early as 2 weeks before the assignment is due, you can have your workbook open and we can talk through it, and you can be taking those notes and glossing it with any other notes. When you finish that, when you have your workbook completed, then you can take the workbook quiz. So the workbook quiz will ask you some questions. Let me show you what that looks like in this case. Ooh, there's going to be a timer. I've only got 5 minutes. So the parameter is a number calculated from the population. So I submit this and it says, yep, that's correct. And the timer's still going. I've got 4 minutes and 46 seconds. Interval data that is ordinal, but you can now subtract. Probably shouldn't go through all of this, but you get the idea, right? It's asking me questions from the workbook. I'll submit that. Might as well just show you the next question. An observational study when the investigator collects data merely by something or asking questions without changing anything. Now, this isn't asking you to make up an answer. This is asking you, I'm going to go back to the page we were just at, to have your workbook open, to have just gone through it, and you'll have all those answers laid out for you. So that workbook quiz will open your attendance. Now, the Chapter 1 attendance is not open right now. Remember, I'm on the student side. I'd have to commit to complete the Chapter 1 workbook quiz with 100% in 5 minutes. In other words, I have to have my workbook complete and ready to go. Now, the homework, the Chapter 1 attendance, or all the attendance assignments, only give you 3 tries. So if you want practice, here is an ungraded practice assignment. It will close like all the others. It has a deadline, but I can look at a question. In a study, the data you collect is temperature in Celsius. What is the level of measurement? Well, I can't do division, but I can certainly do subtraction. So I'm going to say interval. Let's see if it's happy with that. It's happy with that. Okay, and then you can always try a new question. You actually get 100 new questions in the practice. So this is optional. You do not have to do it, but it gets you ready for the attendance homework problems. They come from the same place. They're the same problems, just I have a different setting on them. This is not graded or recorded. The other is. The optional practice gives you 100 tries.
The homework itself, the attendance itself, gives you 3. So I'm going to go back again. And once I do the attendance and earn at least 80% on it, I get into the Chapter 1 exam. Now, the homework, I see the answer to each one as I do it, the practice the same way. The chapter exam is not that way. You answer them, and it tells you your score at the end. The problems are the same. It's just the way that they're presented is a little bit different. So let me go in as an instructor so I can show you what that looks like. So I'm going to go down here, and it will let me in because it will let me into stuff I've created. So once you click on this, notice that it's an exam. You have 90 minutes, so there's actually a timer again, just like on the workbook quizzes. And you have 2 attempts on each question. Not 100 like the practice, not 3 like the homework, just 2. And then as a reminder of what a time limit and a deadline means, it means that you have no answers will be recorded after 90 minutes or after 11 p.m. So there's 9 points possible, there's a deadline, and there's a time limit. So I guess I'll look at a preview. Notice how you can look at all the questions together. So here they are, and you can answer them and submit them, but you won't have that check answer box there. So I'm backing out of that. I'm going to go back up to the student side. I'm going to close the class resources. If you are the kind of person who is willing to help out other people, you're going to click on the attendance or the homework forum without having a question, just looking to see if anyone else has a question. But let's talk about where questions come from. So I'm going to go into the attendance questions, and I'm going to start this. And I am going to point out to you that there is a post to forum link. So if you've got a question with something from the attendance assignment, you can post it to a forum. And what's nice about this is notice that the question in its entirety, and at this point in the semester there's just words, but later in the semester there'll be all sorts of symbols and fancy notation, and all that will come over with this. You'll then click in the top and say something like, I was able to get this far and noticed this issue, and then I did not know what to do next. Was that a good start? Should I have done something else? Something along that line. You're talking to a fellow student when you type these. I'll certainly look at the questions and the answers, but basically this is for your fellow students to help out. And then you'll go down here and you'll click Post Thread, which I think I'll need to pull that up for you to see. So there's Post Thread down there at the very bottom. Okay, so there's our forums. We've talked about the chapter exams. We've talked about that mastery model. With the requirement that you get 80% on the attendance in order to get into the exam. Okay, so there is My Open Math. You'll get used to it. It allows us to do a lot of things correctly with correct mathematical notation, with graphs, with tables, with all sorts of good stuff. Sometimes I throw in some extra videos that I either mention in the workbook video or are just interesting. So here's one about how easy it is to ask leading questions, and another from classical statistics about how you talk about cause and effect. Okay, so that's our look at the syllabus and My Open Math. Let's look at the next page. I want to talk about my role, how I conceive of teaching, how I conceive of encouraging my students. I teach with the carrot, not with the stick. There's lots of carrots, that is encouragements, if that's a word, things to encourage you to work consistently throughout the course of the semester. The stick is kind of that intimidation, that kind of command role. I much prefer teaching with incentives. I see myself as the guide, but you'll be doing the work. That means at the end of the semester, that achievement is your own. My student evaluations are excellent, and I think one of the reasons is Perhaps not at the beginning of the course when it's a little bit daunting, but by the time we get into it, it's really nice to have the course broken into a lot of manageable pieces. And when you look at the challenges and the projects and all sorts of stuff that we do, that you can see that. And the goal here is for you to have the tools to do the work yourself. Now, here's one of the things that is in this discussion today that is not in the syllabus. Now, the deal with memorizing is less of an issue. You've got your workbook with you. You've got all sorts of stuff with you as you work through that. The final is more of an issue. And I think many times when we conceive of what it's like to be in college, that idea of cramming for the final is a big deal. And that's a trap. If you put yourself in that idea that at some point in December you have to learn all this stuff, it's just not going to work. You have to work consistently over the course of the semester. Now, one of the things that I have is a lot of data from students over the semesters. And there's something called data mining where you just look for patterns within data. And one of the things that I've discovered, that if students work consistently, then their final score doesn't really provide me any new information. So let me see if you agree with this. If you earn at least 70% on each chapter exam, that's the lowest you can earn and still have a passing score. Notice that's not an average, that's the score on each one. This is not someone who does really well on one thing and then really poorly on the next. This is someone who's always doing consistently well, at least passing, at least earning a 70% on each chapter exam. If you're in this situation and you have at least an average of 80%, so 70% is your floor, 80% is your average, then you can keep your grade at the end of the semester. Now, your grade is built up of many different things, but basically this says that one of those things isn't the final. In other words, when we get out there towards the end of the semester, after you do your exam for the documentary, and you're in this situation, you've got at least a 70% on the chapter exam, and you have an overall average of at least 80% in the course, then you can keep that score. This is a pretty darn good deal. So if you've been wading through the syllabus and getting R installed and all that good stuff, this is a reward to you. This also is a reward to anyone who takes me seriously in terms of how I've set up this course. There's an exam for every chapter. There's 2 midterms. There's a lot of work that ensures that you're working consistently throughout the course of the semester. And I've done that for exactly that reason. If you work consistently, if you do what you need to do, then you will pass. That's what this says. You can keep that score at the end of the semester without worrying about a final. One of the other things, and some of you have posted this in your forum posts, there is a degree of stress about anything new. I've done statistics and mathematics for a long time, so it's not new to me. When I encounter a new part of statistics or a new paradox in statistics, I'm interested, but I don't worry too much about the fact that I may not understand it to begin with. I may have to make up my own examples, a simpler example, play with it for a little bit, change the context. It's easy to do things that are familiar to you. It's harder to do stressful things. And let's talk about where that stress comes from. If this course is stressful to you, that probably means that it's valuable to you. Probably means that it's important to you. Now that's a good thing. Look at that and say, well, that means I really want to get a college degree. I really want to be able to understand the world statistically. Now there are ways to make stress into motivation. One of the ways is when you feel stressed, get out the book and just read a sentence, a paragraph. Look at something, look at a diagram, pull up My Open Math and do one question. There's always a way to deal with stress that is useful, and that is turning towards, in this case, your homework, your assessments. Looking through your notes, looking through the workbook, rereading the text, watching the videos again. All that reduces stress. You're doing everything you can at that point. The next thing that I want to say, of course, is somewhat obvious. In our society, we think that things are easy if they're familiar. So you'll often hear people say, oh, calculus is easy. Well, that's because they're doing it and it sounds kind of fun to say that. And equally in our society, there's the temptation to say that new things are hard. So there's no need to use those words, easy and hard. If you're going to stick out a degree in math, science, engineering, medicine, that means virtually everything is going to be new to you for the next 4 years. Instead of thinking of it as being hard, simply think of it as being new. A note on placement. Lots of people, there's kind of this received wisdom that everyone has to take statistics. That is not in the least bit true. And I want to point this out. Most majors at CSUS, that is California State University, Sacramento, do not require this course. So make sure you're in the correct place. Make sure that you're a science major, an engineering major, nursing major, math major. Make sure you're in the correct place. I can't help you with that. That is something for a counselor. But it is a fact that most majors at our nearest four-year school, CSUS, do not require probability and statistics. Okay, the next is a quote. I love this quote. It is, I think of this as meaning that math is the most human of pursuits. So give me a second to read this. Artists and humanists embrace complexity and ambiguity. Mathematicians, in contrast, work by obsessively defining terms and stripping off extraneous meaning. The almost neurotic insistence that every term be rigorously defined and every statement proved ultimately frees one to imagine and talk about the unimaginable. Most people, traumatized by school experiences of mathematics, know all too well that mathematics is the most meticulous and demanding of disciplines. But few get to see that it's also the most liberating and imaginative of all human activities. Absolute precision buys the freedom to dream meaningfully. And I would say that that includes all of the sciences, that includes medicine, that includes technology. The idea of dreaming meaningfully. What a beautiful idea, and what a wonderful door that mathematics can open for anyone willing to go through it. Let's talk about some of the myths about mathematics. The myth, and this is out there, so if you haven't heard this, good for you, but I certainly grew up hearing this. Some people are naturally gifted in mathematics. Well, that's not in the least bit true. The reality is that math takes work, and work takes time. If you're my age, you know that you probably could learn virtually anything. I could learn how to play a particular musical instrument, but I know that it would take time. Math in particular rewards people with careful, slow, and methodical personalities. So consider driving. Some people drive well and safely, others don't. And I think that perfectly shows the temperaments that mathematics rewards. How to succeed. Get help right away. This is not a musical instrument. You're supposed to be good at each step as you build the foundation. You don't squawk and screech initially. You just set your sights on learning the vocabulary, building up ideas slowly. Mathematics builds on itself. Reread your class notes. Look over those quizzes. You can take screenshots of them. And exams. Explain to yourself how you knew what to do in each step. There's free online tutoring. And then, of course, cut back on other things. There's no need to have a car during a pandemic. The bus system is running fine. After the pandemic, work here. Join a club. Socialize with college students. It's much easier to convince college students that you have to go home and study than it is to convince someone who isn't going to college. It's also much easier to convince a college student that you're just really tired, too. They'll certainly understand that. Attitude is essential. You have nothing to fear but fear itself. I mean, that's what got the United States through the Second World War, is that confidence. FDR, addressing the people of the United States, says you have nothing to fear but fear itself. And you might say, Well, there's a lot of really scary things that were happening during the Second World War on two fronts, on the Atlantic side, the Pacific side. People here in this country with sympathies towards the Nazis. And what does our president say? You have nothing to fear but fear itself. And imagine how that would feel to someone in those times, or in our times for that matter, to hear a phrase like that. You have nothing to fear but fear itself. If you can conquer fear, then you're in good shape. The last is going to be a discussion of game theory, so I'll go over that. And one of the kind of sad but true statements from game theory is that people do not act in their best interests. So in a lecture class, I'd show some videos of some folks who did some pretty amazing things. Rick Barry was a phenomenal player, and if you're interested in bowling, you know who Jason Belmonte is. And we'll end with the climate change project. Okay, as a kind of reward for following along through that discussion of the syllabus and MyOpenMath and the texts and the calculators, everything else, here's our climate change challenge. This is entirely optional. You don't have to do it if you don't want to. I'll only use those people who participate to compute if the class made it to what it needed to. So basically, I'm giving you 40 points. And if you invest 0 points, so if you put a 0 in that amount invested column, then you'd save 40 points. You could use those 40 points over the course of the semester. So you have an opportunity to earn up to 40 points. You must choose to invest some amount between 0 and 40 points. You could invest 0 points, in which case you'd save 40. You could invest 40 points, in which case you'd save 0. The rest is saved. If the class average of the investments is at least the amount needed, then you may keep your saved points. Otherwise, all the points are lost. So basically, this is one of those questions where you don't know what the amount you need to invest is, but if you don't invest enough, then you're wiped out. So climate change is a perfect example of this. This is a question from game theory. It's an interesting question because it really isn't between you and the question. It's about the rest of the class. Many students will say, well, I'll invest a little bit, hoping that it'll work, and then there's a chance that I'll save a lot. Maybe they'll invest 10 points, and then they'll keep 30. But almost certainly the class average needs to be way more than that. I'm not going to tell you exactly how many points the class average needs to be. This is about your expectations for your colleagues. Do you imagine that they will be interested in saving as many points as they can? In which case they'll invest a lot. If you invest 30 points, and think about this, if everyone in the class took this line of reasoning of investing a lot and only saving a little, then almost certainly if everyone invested 30 points, then that'll be enough, and you can save, everyone would be able to save those 10. But the moment you think about this, the moment you think, well, if everyone did that, everyone would get 10 points, then what's the disincentive for someone to say, well, maybe I'll only invest 10 points. Then I get to save 30 and the rest of the class will carry me along. Now, some of you might say, well, I'd rather have something than nothing. And really, that's kind of an obvious statement if you're thinking about this in a very rational way. But you don't think about this as one person. You're thinking, how are the rest of the class going to respond to this? Email to me. Tell me how much you want to invest and how much you want to have saved. Send me that by Tuesday night. And I will find the average, and I'll tell those folks who sent me the email what the result is. You don't have to do this, but I really would be interested to know what your reasoning is for your choice. There's no real correct answer here. The only correct answer would be a very logical answer in the sense of I invested a lot because I'd rather get something than nothing. But, you know, we're people, and this is the mathematics of the way people behave in groups. It's called game theory. And so I am curious what you think about this. You may have other ways of conceiving of this problem in your head. Again, entirely optional. You don't have to do this. But if you do, send me an email with the title being climate change or game theory, something along those lines. Climate change would help me out for this semester. And the amount invested, the amount saved, and then your discussion of why you choose that. And with that, welcome to a new semester. Welcome to a look at statistics.